In this lesson, we'll be using the shaft and holder clearance. After completing this lesson, you'll be able to use shaft and holder clearance to avoid collisions. Let's carry on with the file from our previous example, and let's talk about shaft and holder clearances. For this, we're going to get started by modifying our multi-axis toolpath again, and we want to start by changing our curve selection to be this boss edge right here. We're also going to go into our passes and we're going to modify our maximum tilt value back to 180 and say OK. Once this toolpath is calculated, let's go ahead and simulate it to take a look at some of the collisions. Because of this specific area, you'll notice that the holder goes right through the part, and as it rotates around, we're also hitting the fixture. Now, while the fixture was defined inside of our setup, it's not necessarily going to be used for collision checking. While the fixture was created inside of our multi-axis setup too, and it is able to see a collision between the holder and the fixture, the functionality we're going to take a look at now is not going to avoid fixture collisions. But for this, we want to go into our toolpath once more, and on the Tools section, we want to go to Shaft and Holder. There are multiple types in here, such as trimmed, detect tool length, and fail on collision. And for our purposes, we want to use trimmed, and notice that we have a holder clearance of 0.2 inches and a shaft clearance of 0.04. If we say OK, it'll recalculate this toolpath, and now it should keep the holder at least 0.2 inches away from our part at all times. Now that the toolpath is calculated, let's go ahead and simulate this. I'm going to view it from the top. I'm going to manually drag through the playback. And notice that the holder never gets anywhere close enough to touch our part. Because of that 0.2 clearance, it's keeping it away, but again, it is still colliding with the fixture. So as we rotate around, you can see that the holder itself comes down with the fixture. And we need to manually control this collision by utilizing some of our maximum tilt angle values and using those options to help avoid the fixture itself. So now in this case, using the option for shaft and holder clearance allows us to continue to machine all the way around the part, but it allows us to do that without hitting the part itself. We can come back into the maximum tilt value and we can change this to 90 degrees. And of course, in reality, to clean up this edge, multi-axis positioning would be a great option rather than doing a simultaneous multi-axis contour. But again, the purposes of our videos are to make sure that we can learn and understand the tools that we have available. So again, here you can see that we are 0.2 away. It's coming in and it's cleaning up this edge using that maximum tilt value of 90 degrees. It's now not able to get all the way into the upper section of this edge, so we will have to modify those angles to get a little bit higher up into that contour. But this has been a look at our multi-axis contour toolpath and all of the options that we've explored. For a quick reminder, we took a look at shaft and holder clearances. We made our selection here and we didn't modify anything such as tool orientation, but we took a long look at all of the options inside of our passes section. We changed the cutting mode as well as the sideways compensation. We took a look at the axial offset, the pass overlap, and the tilts in the forward and sideways directions, as well as the min and max tilt values. You can use all these options to help you create these multi-axis simultaneous contours and help you clean up some of the edges of your complex parts. For our purposes, let's go ahead and save this file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.